Hi everyone and welcome to my channel. In this video I will teach you about smart pointers in C++, but first I want to say hi to everyone who's watching this video as a premiere. And if you're not, make sure to subscribe and click the bell icon because we are always hanging out in the chat section and I answer your questions during the premiere of the video. And also you can follow me on Instagram. It will be here. I post when something interesting happens in my life, and something interesting did happen a few days ago, which is that I fell and I almost broke my arm, as you can see. So I am 26 years old and somehow I managed to be clumsier than a 6-year-old. So let's talk about smart pointers in C++. And the first thing that I want to explain is, what are smart pointers? A smart pointer is a container or a wrapper for a raw pointer. And if you're not familiar with raw pointers, make sure to watch my C++ pointers playlist. I explain everything that you need to know there. And one advantage that smart pointers have is that they deallocate memory automatically, which means that you don't have to worry about potential memory leaks in your program. There are 3 different types of smart pointers in C++. Unique pointer, shared pointer, and weak pointer. And in this video, I'm going to teach you about every single one. So in order to use any one of these 3, the first thing that you need to do is you need to include memory. So I will say include memory like this. And the first type of smart pointers that I want to talk about are unique pointers. So the syntax of creating a unique pointer is a little bit different if you are used to raw pointers. So I'm going to show you now how you can create a unique pointer. So you say unique ptr, and then you specify the type. So what kind of data type is going to be stored on the address that you want to point to. So let's say, for example, integer. So please make a unique pointer to integer, and let's call that pointer unptr1, so unique pointer 1. Okay, and then there are few different ways to create a unique pointer, and the one that I use most often is make unique method. So I'm going to say make unique. So please make a unique pointer of integer type. And to that address, I want to store a value of 25, for example. Okay, so with this, I have successfully created a unique pointer to an integer, and I have assigned the value of 25 to that address that my unique pointer 1 is pointing to. So now the question is, how do you use this pointer? And as you already know, pointers store address. And in order to access the value that is stored on that address, you need to dereference that pointer. So how do you dereference a smart pointer? The answer is by using asterisk symbol or that little star symbol. Let me show you. So if I say cout and then unptr1, like this. So if I write out this unique pointer 1, let's see what is going to happen. Okay, as you can see, we have an address because pointers store addresses. Now, in order to access the value that is stored on this address, you need to dereference that pointer. So let's do that. And in order to dereference this pointer, you put asterisk symbol before it. Okay, so if I run my program now, as you can see, here we have the address that our pointer is pointing to, and then this is the value stored on that address. There is one very important thing related to unique pointers, and that is that they cannot be shared. So in order to demonstrate what I'm talking about, let's delete this code here, and let's create another unique pointer. Let's say unique ptr of int, like this, and let's call it unique ptr2, like this. Okay, so what is going to happen if I try to assign to this unique pointer 2 the same location that my unique pointer 1 is storing? So if I do that, as you can see, we get an error, and that means that you cannot share unique pointers. Okay, Now, one thing that you can do is you can move the ownership of a unique pointer. So what you can do is you can say that your unique pointer 2 is equal to, please move the ownership of my unique PTR1, like this. And now our unique pointer 2 becomes the owner of this memory address here. So if I try to write out the value that is stored on this address here, let's see what we are going to get. Okay, so I am writing out the referenced unique pointer 2. Let's run our program. Okay, as you can see, we get the value of 25. Okay, now one very important thing is that once you move the ownership of a pointer, the previous owner, which is this one, becomes null pointer. And that means if you try to access the value of your pointer that was previous owner, you are going to get null pointer exception. So let's demonstrate that. Let's say, please write out the referenced value of my unique pointer 1. And let's see what is going to happen. And as you can see, we get an exception because now our unique pointer 1 is empty. It is null pointer. And if you are not familiar with exceptions, if you don't know how to work with exceptions, you can watch the video that I will link here, and I will also link it in the description. It's called exception handling. And there I explain everything that you need to know in order to work with exceptions in C++. Another important thing that I mentioned about smart pointers is that the memory is deallocated automatically, which means that you don't have to worry about deallocating the memory or causing memory leaks. And what I want to do now is I want to demonstrate that. So basically I want to create a class, and inside that class I want to create a constructor and destructor. If you don't know, a constructor is a special type of method that is invoked when an object is constructed or created. And then a destructor is also a special type of method that is invoked when an object is being destroyed. So if you are not familiar with the concept of objects, classes, constructors, destructors, and so on, I am going to link a playlist here, which is C++ object-oriented programming, and I will also put it in the description. So C++ OOP or C++ object-oriented programming, you can watch that playlist in order to understand in more detail what I am talking about. So as I said, what I want to do now is I want to create a class. Let's call that class my class. Okay, and inside this class I will create a constructor and destructor. So let's first create a public constructor. So I will say public and then my class. Okay, this is a constructor, and inside constructor the only thing that I want to do is I just want to say constructor invoked. So I will say cout and let's say constructor invoked, like this. Okay, and I also want to create a destructor. So I will copy my constructor. I will put squiggly before it. I believe this is called squiggly or tilde sign. And I will write out here that destructor is invoked. Okay, I hope that I didn't make any typo here. Okay, so I have created a class called my class, and inside it I have a constructor which, as I already said, will be invoked when an object is created. And then I also have a destructor which will be invoked at the end of the life of that object, which means when that object is being destroyed. So what I want to do now is let's delete everything from our main function because we don't need it. And what I want to do is I want to create a pointer to an object of this class here. So let's create a unique pointer like this of my class. And let's again call it unique PTR1. And I will make unique pointer of my class like this. Okay, So let's see what is going to happen if I run my program now. As you know already, constructor is invoked when an object of this type is created, and then destructor will be invoked when that object is being destroyed. So if I run this program, let's see what is going to happen. Okay, as you can see, we only have this constructor invoked. So when is this pointer here being destroyed? The answer is that this unique pointer will be destroyed at the end of the scope. And the scope of this pointer here begins at this curly bracket and then it ends at this curly bracket here. So at this curly bracket here, this unique pointer will be destroyed. And since this is the end of our program, we don't see that destructor is invoked. So what I can do to demonstrate that is I can create an additional scope. So let's do that. Let's create an additional scope like this. Okay, so now this is another scope. And if I run my program now, let's see what is going to happen. As you can see now, we have constructor invoked and then destructor invoked, which means that here at this 18th line of code, our constructor was invoked for my class object, and then at this 19th line of code, so at the end of its scope, destructor has been invoked, which means that our unique pointer has been deallocated, so we don't have memory leak. So one more time, this unique pointer will be destroyed, it will be deallocated at the end of its scope, which is here. Okay, so that is related to unique pointers, and now I want to explain what are shared pointers. So, as the name itself says, a shared pointer can be shared. Unlike unique pointer, a shared pointer can be shared between multiple owners, and that means that you can assign one raw pointer to multiple owners. So let's demonstrate how that works. So let's delete everything from our main function because I don't need it anymore. And the first thing that I want to show you is how to create a shared pointer. So let's say shared ptr, that is the keyword, and then you specify the type. So the type will be my class, so the class that we created here. And then let's give the name to our shared pointer. Let's call it shptr1, so shared pointer 1. And now I want to use a method called make shared in order to make a shared pointer. So I will say make shared of my class, like this. Okay, so with this we have created a shared pointer. Now, one very interesting thing related to shared pointers is that since you can share a shared pointer, it has the count of all of the owners. So it has the count of all of the references to that pointer. So how can you access that count? Well, there is a method called useCount. So what I want to do now is I will show you that. So I want to write out the number of owners of this pointer here. So I am going to say cout, and then let's say shared count, like this. And let's say shptr1, and then I will use a method called useCount, like this. And this useCount method, as I already said, will give me the number of owners of this location here. So if I run my program, let's see what is going to happen. Okay, as you can see, constructor has been invoked, and then the number of owners of this memory location is 1 because we have only one pointer pointing to that memory location. Okay, let's close this. And what I want to do now is I want to share this pointer. So I want to create an additional owner to that same memory location. So let's create another shared pointer of my class, and let's call it shptr2. Okay, and what I want to do now is I want to assign to this shared pointer 2 the same memory location that this shared pointer 1 is holding, like this. And I also want to write out the number of owners of that memory location after I have shared that pointer. So if I run my program now, as you can see, in this first line, it says that the number of owners is 1. And then in this second line, the number of owners or shared count is 2. Okay. One question that you might have now is, when will this memory location automatically be deallocated? And the answer to that question is, the memory location will automatically be deallocated when there are no more pointers pointing to that memory location. Now, since that memory location has multiple owners, every single owner will be destroyed at the end of its scope, and when there are no more owners, the memory location itself will be deallocated, which means that that memory will be free for other programs and other applications to use. So let's demonstrate that as well. What I want to do now is I want to put this here into an additional scope. So let's do that. Let's create an additional scope like this. And what I want to do now is, after this scope, I want to write out the count of the owners of this memory location. So let's run our program and let's see what is going to happen. Let me know what you expect to happen in the comment section before I run the program. Okay, so as you can see, this first line says that there is one owner of this memory location, and then we entered inside this scope here, and it says that there are 2 owners. And then after we have left this scope, this third line, this third print says that there is again only one owner of this memory location, which means that this shared pointer, so this owner, has been destroyed at the end of its scope, which is this line here. Now, another thing that I said is that the memory location itself is going to be deallocated when there are no more pointers pointing to that location. So in order to demonstrate that, let's put all of this code inside a scope. So I will put the beginning of that scope here, and then the scope will end here. And what I expect to happen is that this memory location is going to be destroyed at the end of the scope of its last owner. So if I run my program, as you can see, okay, let's move this. As you can see, our constructor has been invoked, and that happened in this line of code here, so the line where we made our pointer. And then the first output says that there is only one owner, and that is this 19th line, which says shared count, and then we have written out the count. And then when we entered inside this scope, we created an additional owner, so this second output here says that there are now 2 owners. And then when we left that scope and we printed the output for the third time, we get this line here, which says that again we have only one owner of that memory location. And then when we left this scope here, which is the scope of that last owner, we are going to destroy that memory location, which means that we are going to deallocate that memory so that other programs and other applications can use it. So that was related to shared pointers in C++, and now I'm going to teach you about weak pointers. So the main difference between a weak pointer and a shared pointer is the following. As you already saw, when you assign a specific memory location to a shared pointer, that is going to increase the number of owners of that memory location. But if you assign that same memory location to a weak pointer, that will not increase the number of its owners. And that means that we use weak pointers in order to observe objects in memory, but a weak pointer will not keep that object alive. So we use weak pointers in order to locate a specific object in memory, but a weak pointer will not keep that object alive if nothing else needs it, whereas a shared pointer will keep that object alive. So let's demonstrate what I just explained. So let's delete all of this code. I don't need it anymore. By the way, deleting code is my favorite part of coding. So the first thing that I want to do is let's create a weak pointer. Let's say weak ptr of, let's say for example, int. So let's create a weak pointer to integer and let's call it wePTR1. wePTR, okay. So another thing that I want to do is I want to create an additional scope like this. And inside this scope, I will create a shared pointer. So let's say shared ptr of int, and let's call it shptr1, so shared pointer 1. And let's make one shared pointer. So I'm going to use method make shared. So please make shared pointer of int, and let's assign the value of 25 again. Okay, so after I have created a shared pointer, what I want to do is I want to assign this same memory location to my weak pointer. So let's do that. Let's say that weak pointer 1 is equal to shared pointer 1, like this. Okay, so let's see what is going to happen if I run this program. I'm going to put a breakpoint here, so at the first line of my main function. And if I run this program, let's see what is going to happen. So now we are debugging this program. Okay, so in this first line, we are going to create a weak pointer, and it is still not pointing to anything. As you can see, it is empty. We just created it. We didn't assign any location to that pointer. Okay, and then after we have created that weak pointer, we are going to enter into this scope here. And inside this scope, the first thing that happens is we create a shared pointer, and then we assign the number 25 to that memory location that our shared pointer is holding. So let's do that. Okay, and if I hover over my shared pointer, as you can see, it is pointing to a memory location that has one strong reference, and on that memory location we are storing the value of 25. Okay, now in this second line of code, we will assign this shared pointer to our weak pointer. So if I execute that line of code, let's hover over our weak pointer, and as you can see, now our weak pointer as well is also pointing to the same memory location, and that memory location stores the value of 25, and it has one strong reference. But one thing that will happen when I leave this scope here is following. Please write me in the comment section, what do you expect to happen after I leave this scope here? So if I press F10 and leave this scope, and if I hover over my weak pointer here or here, there are two things that you can notice. The first thing is that it says that there is only one weak reference to this memory location. So there are no more strong references. And then another thing is that it has expired. So all of the owners, all of the strong references to this memory location have been destroyed. And now we have just a reference. We just have the address of a memory location that has been deallocated. And that is exactly what I've been talking about, which is that a weak pointer will not keep an object alive, whereas a shared pointer will. So this memory location has expired. It was deallocated when its last strong reference, so when its last shared pointer or when its last owner left its scope. And that happened on this line of code here. So I hope that this video was helpful. If it was, please give it a thumbs up for the YouTube algorithm, and also share it with someone who would like to learn programming, because many people would like to learn programming but they just don't know where to start. So you can be the one who helps them and makes the difference. And also, if you have any questions, you can leave those in the comment section, and please let me know what kind of videos you would like to see in the future. So thank you very much for watching, and I am going to see you in some other video. Bye!